Today we will study addition reaction in alkenes. Okay. So what is addition reaction? Addition reaction is the reaction in which only one product is formed. And which type of hydrocarbon show addition reaction? Addition reaction is shown in alkenes. Okay. Now alkenes, we need to know three type of addition reaction in alkene. Number one, addition of hydrogen. Number two, addition of steam. And number three, addition of aqueous bromine. Okay. Now let us start with addition of hydrogen. So whenever hydrogen is added to alkene, that type of reaction name is hydrogenation. That reaction is called hydrogenation. Okay. So when when hydrogen is added, always the product is alkane. Okay. The product when hydrogen is added to alkene is alkane. The condition for this reaction is we use nickel as a catalyst. You see, very nicely, it is a very easy reaction because you just make any alkene. Here I made ethene. You make any alkene with a double bond, then add hydrogen to it in presence of nickel. Repeat the structure of alkene with a single bond and now show the two new bonds formed to which this and this hydrogen get attached and it become alkane. So since we are taking ethene, that's why ethane is being formed. Okay. Now this type of reaction is very important because you can make alkane out of alkene. Very easily alkane can be made from alkene only just by adding hydrogen. But you have to remember one thing, okay, nickel must be present there as a catalyst, otherwise the reaction will not take place. Okay? Now in our day-to-day life where we use this reaction, we use this reaction for making of margarine. For making of margarine. What is margarine? Margarine is a vegetable fat. Okay? We make a vegetable fat from a vegetable oil. Okay, and vegetable fat, how it is used? Margarine is used as a butter. Margarine is a substitute of butter. So you just understand that we are making butter from the vegetable oil. Actually, the butter is made from animal fat. Butter is an animal fat which we make from milk. But here we are making margarine from a vegetable oil. By which process? By hydrogenation. Because vegetable oil is what it is? It is an alkene, and when we add hydrogen to it, it becomes vegetable fat, margarine, which is alkane. Okay, so this is your application of hydrogenation reaction. Next, coming to addition of steam. Now, in addition of steam, when steam is added to alkene, the name of this reaction is called hydration because we are adding water. And then you see it is simple, it is same like that. Whenever we add steam to alkene, the product is alcohol, and we should know, we must know that here we are using catalyst, phosphoric acid as a catalyst, and heat is needed here because you know that steam means you need, it is not taking place at room temperature, heat is needed here. You see this, the reaction is also very easy. We'll just make a ethene with a double bond and then we add water to it in presence of phosphoric acid. The two new bonds, you'll repeat the structure with single bond and two new bond. To two new bond, one H is added, one OH is added, and so the alcohol is formed. Okay, now what is the importance of this reaction? It is very important reaction because you can make alcohol from ethene. You can make alcohol from alkene. Here we are using ethene. That's why ethanol is formed. We can, whatever alkene we will use, depending upon that, alcohol will be formed. Okay, so today we are going to discuss a very important topic, that is addition of aqueous bromine to alkene. So when we will add aqueous bromine to alkene, what will happen? We have already discussed in our previous class that alkene will always undergo addition reaction. Okay, and what is addition reaction? When only one product is formed. Okay? So first let us understand this reaction. When aqueous bromine is added to alkene, the product form is dibromoalkane. Okay, and here in this case we don't need any condition. This reaction takes place in room temperature, at room temperature. Okay, now see the equation. We took ethene with a carbon-carbon double bond. We added bromine. Same reaction happens. We will repeat the structure of alkene here with a single bond, and then we will make two new bonds, and to these two new bonds bromine will get attached and the product is dibromoalkane. Okay, very easy. Addition reaction always happen like this. This double bond opens into two new single bond and the reactant get attached to these bonds, and that is why only one product is formed. Now this reaction is very important because this reaction is used for testing unsaturation. This reaction is used for testing unsaturation. What does it mean? In an organic compound, if carbon-carbon double bond is present and we add bromine water to it, the color of bromine water will change to colorless, and this will indicate that carbon-carbon double bond is present here. Getting my point? Again, I'll repeat. This particular reaction, that is also called bromine water reaction, is used for testing whether carbon-carbon double bond is present or not. If carbon-carbon double bond is present in an organic compound, then the orange color of bromine water will change to colorless. Okay, now let us understand this testing with the help of one question. Question is this: there is two compound A with a molecular formula this, and compound B with a molecular formula this. C17H35COOH, C17H33COH. There is two organic compound A and B, and this is their molecular formula. When we add aqueous bromine to these two organic compound, what will be the result, and explain your answer. This is the question. So now I solve this question by making a table so that you can understand it nicely. Suppose compound A is this. Okay, now I am giving you a trick here how to identify double bond is present or not. Okay, now here you see C is 17 and H is 35. Okay, so here the hydrogen number is double plus 1. Here the hydrogen number is double plus 1, that of carbon number, whereas here the hydrogen number is double minus 1, C17H33. 17 2s are 34 minus 1. Okay, since hydrogen number is lesser here, lesser than double, and here the hydrogen number is more than double of carbon, here the hydrogen number is less than double of carbon. So understand that B is unsaturated. B is having double bond, that is why its hydrogen is lesser than double of the carbon. Here A is having single bond because the hydrogen number is more than double of carbon. Okay, now so this is the trick. Very complicated molecular formula is there, but you don't need to worry. You just check the number of hydrogen, whether it is more than double of carbon or less than double of carbon. If hydrogen number is more than double of carbon, which is present here in A, so there will be no change in the color because why? Because A is saturated hydrocarbon, carbon-carbon double bond is absent. Okay, so if there is no carbon-carbon double bond, color will not change. Where this bromine will get attached? If no bromine get attached, that means no color change. That happened in case 2, which is B. Hydrogen number is lesser than double of carbon number. That's why the color changes, because there is double bond here present, which will open and 2Br will get attached. So you see this because carbon-carbon double bond is present, and that is why the color change. Okay, so it is a very important reaction because it helps us to understand whether double bond is present or not.